SFAM. Then similarly, the overall best PhD thesis that's during the year 2007 and 2008 session in the University of Lagos. Ditto for the overall best for the Faculty of Science. And similarly, the Award of Excellence by Christian Progressive Cycle, CPC, of Yaba Baptist Church, Sabo Yaba. Then similarly, he was also recognized as the overall best student of the Department of Microbiology in the University of Lagos in 2008. And going furthermore on this, she got lots of grants, which include TET Fund, that's a Tertiary Education Trust Fund, and in some conference attendance, as well as some grants by the University of Lagos. Just to be brief on this. And to round this off, she's a member of the Nigerian Society of Microbiology, which is our major discipline, and the Institute of Public Analysts. And I believe we are all members as we are sitting down here, an Association of Industrial Microbiologists of Nigeria. Similarly, too, we have some of this association offshore, which includes the American Society of Microbiology. I've already mentioned SFAM, and as well as the Organization for Women in Science for Developing World. This one now is also to even encourage most of our women to in areas of research and development. She has attended several local and international conferences, and her research work has been published both locally and internationally. So you are utmost welcome to give us a beautiful presentation. So while our audience will listen attentively for the very good moment of presentation. Thank you. So you will be on for 20 to 25 minutes, thereabouts.
Pleasure to be here this afternoon. I didn't know I would be the first person presenting today. I wasn't expecting it. I have two papers I'll be presenting this morning. I thought it was just a casual thing, but FIPAN said no, you cannot come here and just escape like that. So turning my paper presentation for the abstract session into proper paper. So the first paper I have is on bacterial and physicochemical assessment of potable water from all sub-presidents of the University of Lagos, University campus in Lagos Metropolis. I worked with nowadays research is a disciplinary attack. Interdisciplinary, so we don't just work alone again. I work with people in chemistry department, Professor Olusheyi, Professor Dr. Fatusi, and student William Osuji. So we'll be taking a look at the physicochemical assessment of potable water in the University of Lagos. But before we go into that, what is water? Water is essence of life. Over 80% of the Earth's surface is made up of water. The human body has over 70% is made up of over 70% water, and even microorganisms over 80% of water. It's a natural resource. It's a natural resource, and one of the most important natural resources. However, the presence of the availability of water is a threat because the one that is used, the one that is available to us is the fresh water, is the one that is fresh. Water can be salty, can be from the ocean or surface water. The potable one that is available to us um, is usually found underground or in the surface and is threatened by a lot of factors, majorly due to human activities, our domestic activities, our industrial activities, agricultural activities usually threaten, contaminate the water environment. And that makes it very important for us to study, assess the water that we find in our various communities and see what we are taking if we are at risk from taking them. Um, the aim of this study was to investigate, just like topic, the physicochemical parameters of the potable water that is found within the hall of residences in University of Lagos. So we went around 15 halls of residence and we took the water at ransom, usually midstream. And we also look at the bacteria from this environment. We look at the bacterial load. We isolated the bacteria from this environment, and we try to look at their antibiotic profile of this bacteria. So, set sample collection collected from 15 halls of residence. The parameters, so chemical parameters that we look at were the total dissolved solid, dissolved oxygen, pH, salinity, electrical conductivity, and the temperature of the environment. And what we used in the assessment of these parameters was the Horriba U52 multi-parameter water quality meter. For the microbiological analysis, we did the total heterotrophic count, the total plate count of both the bacteria and the fungi. Even though we are more interested in the bacteria, we also look at the fungal load. And because it's potable water, we are looking at also residents of students take this water. We look at the coliform level. When you talk about potable water, you cannot but test the coliform level in it, detect it, and also enumerate it. Then we went further to identify the organisms that we got from these water samples, and the organisms were subjected to antibiotic susceptibility testing. Now the results. So, so most of the next slide. For the physicochemical parameter, most of the parameters tested fell within the acceptable WHO and EPA limit, even the some limits. However, we found that the pH of the medium of the water samples were way below. They were on the acidic end, which is far below what is expected by WHO standard. Also, the electrical conductivity was okay, dissolved oxygen. For some of the water samples, it was all right. Dissolved oxygen is an indication of microbial load within the system. The electrical conductivity is dependent on the total dissolved solid, and they were both within this. All the other parameters, except for the pH and the turbidity, were outside of the limit accepted by World Health Organization. The next slide. That's for the parameter, physicochemical parameter. For the microbiological analysis from the halls of residence, found that the WHO limit is 1,000 colony forming units per mil of the sample, whether bacteria or fungi. And we found out that some of the halls of residence, the total bacteria count in there was above the acceptable limit, which indicates the contaminants within that environment. For the fungal heterotrophic count, some of the water samples had growth, whereas some had no growth, which shows that they were free of fungal contaminants. Next slide. Then we went on to do the coliform count, because we are talking about potable water now. We are talking about water. We do coliform count. It's an indication of fecal contamination. According to WHO standard, there shouldn't be coliform potable water. However, we recorded very high levels of coliforms in all the water samples, and that makes them unsafe for drinking. So, next slide. So this is the MPN coliform results of the water samples from the all compared to WHO standard. So in some of the halls of residents, you can see the bars, the red bars, indicating very, very high coliform count, and that shows that these halls actually need emergency intervention to see to the water supply within the hall. The yellow bars less, and the green ones indicate safety. Then the bacteria that were obtained from the total count, we went on to isolate them, purify them, and identify them. And upon identification, we found we had 8 genera of bacteria. Next slide. So we had 8 genera. We had Klebsiella genera, the genus Klebsiella, Escherichia, Enterobacter, Pseudomonas, Proteus, Staphylococcus, Providentia. These were the genera we isolated. And in order of distribution or occurrence in the water samples from the hall, we found that we had more of Klebsiella, Escherichia, and Enterobacter. You know, earlier on we said that the coliform levels were high. Klebsiella, E. coli, that's E. coli, E. coli where we enter bus, E. coli, Staphylococcus that is spread out. So they were very high. So the very high values, they all came from coliform samples. So that really indicates that those water samples were really, really contaminated. Then we went on to do the antibiotic susceptibility test. So some of the organisms were gram-positive, like the Klebsiella. All the coliforms were gram-negatives, and the gram-positive one was the Staphylococcus aureus. So we tested them against some antibiotic disc in the laboratory. So let's see the results. So the results I have. So there was a general resistance to Ampliclox, a 100% resistance to Ampliclox. So the isolate, the granular Ampliclox, cefotaxime, cefuroxime, all of them, the organisms they showed a 100% resistance to them. For the bacteria, there was complete resistance to amoxicillin, Ampliclox, and ceftriaxone, for full sensitivity to ciprofloxacin. Meaning, if somebody is infected with for the gram-negative, please don't administer antibiotics without seeing a doctor. I believe we all know that. The only antibiotics that will work for you is the ofloxacin for gram-negative and ciprofloxacin. And I know that when we are sick, we just go to the pharmacy. I have this, I'm purging, give me antibiotics, and you just buy antibiotics off the counter and administer. And we will know that the antibiotics we actually applying does not have an effect if it's a 100% resistance to Ampliclox. I remember there was a time, anytime we go, Ampliclox is the solution to all illness. The Ampliclox no longer works. So what we are just doing is we are just building antibiotic resistance and increasing antibiotic resistance in the environment. Okay, so this table shows the susceptibility pattern of the gram-negative bacteria to the various antibiotics. So we can see the Ampliclox, the ACX, that's the 100% resistance, and we have them to 100%, 96, 64, 87. Those are very high resistance. Meaning, if we go to the pharmacy and buy antibiotics over the counter, they will not work for this isolate. The infection will just persist. Okay, so the next one too is also showing susceptibility pattern to another set of antibiotics by the negative organism and the gram-positive organisms. So, table 6. This table 6. Okay, so this is the gram negative. So for the susceptibility of gram negative, so you can see they are susceptible. That is, if you do any of these antibiotics, they will kill them. Please, they will kill them, tested in the laboratory, but let's not go and use them because you don't know the organism that is actually causing the ailment that we are having. So, table 6 is for the susceptibility pattern of the gram positive bacteria to the various antibiotics. In conclusion, from the study, we were able to show that most of the physicochemical parameters of the water samples from the all of residents, some of the physicochemical parameters met the acceptable limits for WHO, whereas some of the limits like pH and turbidity was way off the acceptable limit for some of the water samples. The presence of coliform in the water sample indicate that there is a contamination from somewhere within the environment of where the water supply is kept, and that needs to be looked into. And the fact that when they were subjected to antibiotic susceptibility tests, there was multiple resistance to antibiotics. It shows that there is a risk of spreading multiple antibiotic resistance within the environment. This antibiotic resistance is a global challenge right now, and there is a need for us to also carry out some effort in order to curb this widespread of antibiotics resistance in the environment. So the limitations we had while doing this work is the sample size. Even though we had 15 lots of residents, there are other residences within the campus. The water samples within a hall were taken from different points and pulled together. The single point sampling, which will not capture seasonal variation. We did this sampling around the month of February. I'm sure if we had gone maybe during the raining season. The environment where we did it is a wetland. We carried out the experiment in University of Lagos, and it's a wetland. So if we go during the rainy season, definitely we will get a different result because the water will have been diluted by the rain. Additionally, molecular identification technique, we have not identified the organism molecularly. We have identified them based on biochemical characterization. So recommendations now. Based on what we have, our recommendation is for the University Authority, and even beyond the University Authority, even in our various organizations, we should periodically carry out a test on our water supply, and if there are broken pipes or leakages, we should try and fix those leakages up on time. We should promote awareness campaign on safe water use and hygienic practices. We should conduct longitudinal studies with molecular analysis to track resistant trends and sources of contamination in the environment. Then policymakers, we should develop stringent regulations on antibiotic use and water safety standards. This study has highlights the critical concerns regarding the safety of potable water in the university community. The detection of the high heterotrophic load of microorganisms is a big concern. It shows that there is contamination. The multiple drug resistance that was detected in the organism also raises concern for us, and um, therefore we call on the urgent need. We request that the management should step up. They've been doing a lot, but they should step up their monitoring and also dissemination information about keeping our water safe. Thank you very much. I just want to say that I thank the University of Lagos, the sponsor of this large conference.
Okay, thanks for the presentation. Though I myself I have brief maybe inquiry or comments, but we will entertain questions from member of the audience within 10-15 minutes. So that that's a good presentation. Thanks a lot. Okay, okay, maybe I should stand up. 1, 2, 3, 4. I think that's okay. I can round up. Okay, sir. Number one. That should be. And question.
My name is Tayo Fabimi, a retired computer now at AAUA, Adekunle Ajashi University, Department of Computer Science. I just want to find out, it's an interesting presentation, especially when it concerns sharing. I want to find out who draw a relationship between the source of water and the source of wind.
My name is Eric E.B. Jackson, Technical Director, Abraham and Sarah Beverages Nigeria Limited. I would like thank you for the presentation, very good presentation. I want to find out what is the source of the water and is there a functional water treatment plant in the university?
So you asked about the source of water and the soak away. Yes, sir. So those are things we also put into consideration. So we found out that where we had a very high load, there was a recent there was a broken pipe somewhere along the line that was not fixed. So when the students collected, we asked them to look around. They snapped some pictures, but they didn't see that. But it was later we found out that yes, there was a broken sewage somewhere close by, which may have actually contaminated the water supply. And the school immediately responded, even without even knowing that we had a research going on. They immediately responded and did that. But our experiment was already concluded by the time we did that. And the source of the water is borehole, and the school has a water treatment plant in place. But they also support with the borehole on campus. So where we got this water from, we got it from the borehole within the hostel. In fact, what actually triggered this research was some of the students were complaining that their water source was maybe when they fetch, they were smelling things, they were smelling that, and the complaint was so much. So I now said, okay, why don't you go back and go to your hostels and do this experiment? Take your water and let's see what is happening there. So the water source, some were taken directly from the water from the school, and some from the majority were from the borehole system in the school. But the contamination was majorly due when there was a pipe breaking and we were not reported on time. For this.
Let me first comment for the beautiful presentation you have made. My name is Ima Kasim Ademola. I'm the managing director of SoTLAN COPA.
one of my question or my concern addressed, and my other concern is the relationship or the rationale, of the microbial isolates from the water body, the susceptibility of the microbial isolates from the water body to antibiotics. Now that you are now relating, how does it relate to the isolates from human body? Taking the cognizance that the isolates from human body have a different chemical reaction to that of the water body. Part of the issues that can affect that is the usage of antibiotics and that human. Whereas in the water body, of course, we don't know what the water body is. So when you now pick the isolates from water body and put the microbial activity on there, or the susceptibility, how do we relate it to that of isolates from human body? Then also, apart from that, I think you should have gone ahead also where you having polygon, exceller, and so on, which we know as strictly of fecal origin. You should have gone
Strictly what?
strictly of fecal origin, the E. coli, Streptococcus faecalis, and so on. So what we should have done is, let's mark it. Types of other one, and not what is the location of the water body borehole, looking at the water are going around within that area that have polygons. So those are my concerns and questions. Thank you.
All right, so I'll start from the last question, sir. You said we should have set it apart. Water contamination results from human activity. There's what we call cross contamination. Yes, the organisms that we have on our body is different. It's not so different. These organisms are the same. There's cross contamination. We throw our waste, we defecate, we do this, we do that, they spit. So these is particularly our waste products. They get into the water body. So it's the same organism. It's the same thing that we are recycling. Everything is recycled in nature, and there's what you call horizontal gene transfer. These organisms pick it up from the environment. They pick it up. So it can be from the waste that has been left and has percolated, and the leachate has leached into the underground water body, and it enters into the water system. The organism takes it up. The DNA enters. The competent cells takes it up, and they become competent. They become resistant to these strains. So cross-contamination arises because of our waste disposal activities or waste disposal system. And so many waste, like I said, we have domestic waste, we have that sewage and washing and all those. Our laboratory activities, this is a university environment. When we dump things in the dustbin, the cleaner does not know what we have done. They just pack it in and just go and dump it at the general purpose dustbin. And when it rains, the rainwater washes it off and takes it and distributes it around. And indirectly, we take it back. So that's why we must be very, very careful where we dump our waste, because we end up putting our waste back in most cases. I believe I've addressed it.
Okay. Thanks for the response. Before, though, we take you now, sir. But I learned some people are also online. We will allow either one or maximum of 2 questions from them too. So while the last, we entertain the last question from the audience. Madam, I hope there won't be too much questions. But well, after we have
Good afternoon, everyone. My name is Pagong Adebisi. Thank you very much, Prof. Wonderful presentation. Very enlightening, though I'm not a microbiologist or an analytical chemist. So, but I have concern of the value probably your students recorded under conductivity. Probably if show it now because just like our guys have said, the source of water is the raw water, right? There is no way we can have 0.2 micron per cent as conductivity for raw water. I don't, probably because maybe the instrument is set. Maybe it should be in thousand, supposed to be probably 200 plus or something. So that probably the student can check up and probably revert back. Thank you.
Thank you. Noted. I'll pass the information to my colleague who is in chemistry. I do that. Well done. I just want to quickly ask, from your presentation, I need to know the water samples. Are they raw waters or treated waters? I recall you mentioned some were taken from boreholes, some were taken within the hostel. It means that those within the hostel might have not meet whether adequate or not adequate. So if that is the case, will it not be somehow to compare raw water quality to treated water? I'm thinking we're going to separate the treated one from the raw. Then it will inform the management that truly a treatment process is not adequate if it's the treated water that is having this, let me say, contaminations. And then you mentioned that you ask the student to take their sample. Do you think the sampling method or procedure did not impact on the results you're getting? Because it would be good to know if those students were trained, how did they collect the samples, what collection containers did they use, did they avoid contaminations, and the like. And then finally, your susceptibility testing procedure I'd like to know, and then the chemical characterization methods you used. Thank you. All right, that's the whole presentation. So we use the disc method. So we bought commercially available antibiotic disc, and we prepared molar 18 agar, we seeded it with 0.5 gallon standard of the bacterium, and then we placed the disc and we measured the zones. That was how we detected that. The biochemical test, we did the gram staining, that conventional biochemical gram staining, catalase, VP, coagulase motility test. Those were the conventional microbiological chemical tests we did. We didn't do molecular. The sampling method. Okay, so yes, they did. They did. Yes, the sampling method. Because it's microbiology, everything has to be collected hygienically, aseptically, rather. Yes. So the bottles for the collection, they were washed, cleaned, and sterilized in the laboratory before going to the sampling to take samples. And when they got to the sampling point, they had to allow the water to run and collected water. So they allowed the water to run, collected mist cream. When they collected mist cream, they use it to rinse the sample bottle, they threw it away, they rinsed it again twice. Then they now collected their sample so that they'll be sure that whatever is there is representative of what they are taking.
Okay. Thank you. A round up from my side.
Thank you so much, Prof, for that presentation. And I realized that in your results, you have two parameters that have everything in common with all the samples. The pH, all the samples had low pH values. And also coliform, all the samples had coliforms. So, have you been able to check the relationship between coliform and pH? Is there anything that coliform is doing that is
low pH? They tried the low pH. So the pH was very suiting for them. They just swimming in it. It was natural.
Okay, thanks for the presentation, though I'm very conscious of our time. And by emphasis of comments, most of the organisms you encounter there are worrisome. Talking of drinking water sources. And for you to also present this for policy makers, you have to make some corrections, just like the man other pointed out over there. And so for some studies like this too, it's good to even oversee what students are doing. Even for my own school too, I used to analyze some of our water being produced for the university community, at least some times ago. Then, talking of the standard, you mentioned generally that the standard for by WHO is 1,000 counts. Is it total bacteria counts, or you are referring to the? Okay, now for the WHO, okay, I remember. Then because that's where talking of the level of contamination, what is the World Health Organization standard and Nigeria standard? Because even as an analyst, we used to take cognizance of that too.
For the sun, it's the same, 100.
100.
Yes, detect.
See, as a practitioner, it is a concern on the standard of the water, the drinking water, or the potable water, either by the WHO or the NIS. When you say that the maximum limit for total viable cans is 1,000 per mil, 10 raised to power what? No, it's not 100, it's 1,000. Okay, let's even say 100. But the coliform is
Zero.
Whereas
Coliform should be zero.
Whereas the old one was 10, Abi.
Pardon?
The old one for potable water. Yes. Whereas it should not be there.
Okay, so for standards, when you talk about water standards, the purpose the water is meant for also matters. If you are talking about drinking water, potable water, or anyone that is used for cooking, there should be zero. The coliform level should be zero.
Now, but the concern now is this: when you work for customers,
Yes.
that ask a sample from, they say it's raw water. And what standard do you use for their raw water? They call it raw water because they are going to treat it for their own processing. Now,
Raw water when it's surface water.
no, any water, the water they are calling raw water is the water from borehole.
Well,
But they call it raw water because they have to treat to fit their own usage. Now, the concern now is this: some customers who work for them, you use the standard for potable water, international standard for drinking water, or the the NIS standard for potable water. Now they say there is no standard for raw water. So how do we harmonize that?
okay.
How do we be able to convince them that you can still use the standard for that potable water for the water?
Okay, sir. So there is another standard. So um, different communities adopt different standards. So we set our standard. So WHO has a standard, and we can take the lead from them and set our own standard based on the peculiarity of our own community. So I understand from where you are coming that if you have the surface water, the raw water, because the raw water is not potable water, you still have to undergo some processing. There is also a limit. There are some the acceptable limit is instead of 1.0 times 10 raised to the power of 2. There are some 5.0 times 10 raised to the power of 2. So there are acceptable limits. So depending on the water we are looking at, the water will dictate the limit that we actually use when we are carrying out this analysis. So for potable water, for drinking water, the acceptable limit here is 1 times 10 raised to the power of 2.
Okay, anyway, thanks for the response, ma'am. though we shouldn't be. We also even have this regulation in IPAN because I still remember there was a time we normally use even one coliform in 300 mil as part of the standard, but we can still put that forward for another time and discuss. Thanks for the presentation. Okay, she has two papers to present before we go to another presenter. So possibly she can go for the presentation of the second one. So at least by God's grace, within the next 40 minutes or thereabouts, we should be able to finish with the whole session. The online audience too, our technical team there, if there's anybody that raises up and you can let us know, but that will be for the second
The second paper is assessment of heavy metals in groundwater from a local government area of Lagos State, Nigeria. For the people of assessment of heavy metals in groundwater from a local government area of Lagos. So I did this in collaboration with a student, Babalola Mary Adewale from Now University. I won't spend much time on the introduction this time around because I've already said what groundwater is. Groundwater usually gets contaminated due to human activities from our industry, domestic activities, agriculture, and in Lagos State, there was a study carried out in Lagos State by Babatunde and Akinola and Ogundele, and they revealed the harmful levels of heavy metals presence in water from this environment, and they were able to link this heavy metal, the presence of this heavy metal, lead and cadmium, to kidney and neurological diseases, and in some cases cancer. The aim of this study is to assess the concentration of heavy metals in a selected local government within Lagos State, Oshofe local government to be precise. And this local government was of interest because of, if you know Lagos State, when you enter from Ojota, that's big dump site, Olushosun dump site, that is found in this local government. So we wanted to see the impact of the leachate in the underground, groundwater in this environment. And then we wanted to know the public perceptions and public health implication of this metal, the heavy metal presence in the water body. The framework comprises hazard identification, exposure assessment, and which we carried out through distribution of questionnaire, and we collected samples within the environment and tested them also to validate what we got from response from people. So our research question was what are the concentration levels of lead, cadmium, mercury, and chromium in the groundwater? These heavy metals, I want to say here that not all heavy metals are dangerous. There are some that we actually use. The body, and the thing disappear now. So we use copper, for example. We use copper, but in trace amount. Zinc, we use them in trace amount. But these ones, we don't need them in trace amount at all. We don't need them at all. So we want to know the concentration level because they pose a risk to us. They are carcinogenic, they are mutagenic, they causes neurological disorders in humans and in other animals. We want to know if the concentration levels that is in this groundwater, we want to compare it to WHO and NAFDAC thresholds and see if it's within or outside of it. Then we want to know the public perception concerning consuming contaminated groundwater from this local government. Then what strategies can improve groundwater quality and its safety within this environment? Next slide, please. So The methodology we use is a mixed method. So we took samples from 4 different sites across this local government. We took from Ojota itself, where we had the dump site. We took from Ogudu, which is not so far, about 200 meters away, Oworo, Ifako, all around that local government. Then we carried out the laboratory analysis of the water samples using atomic absorption spectroscopy. Then we had a survey. So we distributed 400 questionnaire. We did in distributing the questionnaire, we actually looked at the sampling number, population. Then we did a comparative benchmarking. Results were assessed against WHO. Now the results, we found that the results for the heavy metal concentration, we found out that several of the samples exceeded the threshold, most especially lead. The lead were way high. So lead was up to 0.22 milligram per liter. Cadmium, mercury was within the range. Chromium was within the range, but in particular was the level of lead and cadmium that was very high within this community. 80% of the samples were high in lead, 70% for cadmium, and 50% for mercury. Table 1 shows the results of the sample location where they were taken and the concentration of lead, cadmium, mercury, and chromium across the 10 sampling points. So then figure 2. So this is the concentration of the lead, cadmium, mercury, and chromium in all the sites. So from the Ojota site, so we went to different streets. So just like we collected water sample for the previous paper I gave, they also went with aseptic containers and went to houses within these localities. Went with houses that had borehole and those ones that had well, and they took water samples from the houses within these communities, and we got their consent first to make sure they weren't afraid, because in Nigeria, if you go there and water stops coming out, you are in trouble. So figure 2. So here we have a comparison of the measured heavy metal concentration against the World Health Organization standard and then NAFDAC standard. And we can see here that the level for lead, which is orange color, and the one for chromium was way above the 0.010 limit for the acceptable limit for these 2 heavy metals. I want to say here that different metals have different acceptable limits. For lead, it is 0.01 milligram. For cadmium, 0.003 milligram per liter. For mercury, 0.001 milligram per liter. And for chromium, 0.05 milligram per liter. So they have different acceptable limits in the environment. Now, so that's for the heavy metals. So we're able to show that the level of heavy metals in the water from either the borehole or the well water was way high, above the acceptable limits by the standard bodies. Next slide, please. So we now went over to the questionnaire we distributed to 400 people, and we got their opinion about the health implication of living in a community where a dump site is sited that is over 40 years, and the leachate has seeped into the underground water. Wanted to know about the odor or anything, or if there is any related illness from these people. And 82.5% of respondents acknowledge health risk from the contaminated water source, the one they consume. 80% indicated willingness to support water quality initiative if they see one. So table 2. Next slide, please. So we took the demographic characteristics of the respondents. They were of different gender, almost balanced. So 52 to 47%, that's male to female. They cross across different age range from 18 years to above 45 years, um, the marital status. So it cuts across the diverse demography of people within that community, both age-wise, marital, educational level-wise, and also income earning-wise. So, next slide, please. From the report, then we assessed about 60%, that's from the health implication on groundwater contamination. 60% agree that yes, the groundwater within the community is contaminated. 50% acknowledge that they had suffered health-related issue due to the water they consume within the community. 62.5% responded that they were aware that heavy metals was part of the contaminant in the ground water. Many of them used it to cook. The groundwater, they were primarily used for cooking, for doing all their domestic activities. Then I believe that contaminated ground can cause long-term health issues. About 73% agreed. Adequate information available in my community about potential health risk. 30% of them agreed. So meaning majority of them do not even know that where they are staying, that there could be any adverse effect from taking the water in that community. I regularly experience symptoms, but 40% of them attributed it to the water source. Then on the issue of the government or local authorities having taken measures to monitor and address groundwater contamination in this area, 30% of them responded that they were aware of this, and many supported. 80% of the people that were actually contacted were willing to support any initiative by either the government or NGO in helping to make the water quality better within that community. So, and also concerning noise, odor, the groundwater in my area has an unusual taste, odor. 50% of them responded that the water they fetch, the water they use within that community actually smells and it had odor. Okay, so next slide, please. So recommendation for managing and mitigating groundwater contamination. So some of the recommendations, we asked people if they agree to the recommendations, and one was that Koshofe local government should install water treatment system to prevent heavy metal from entering groundwater. A lot of them agreed. In fact, all the recommendations that were put forward, they all agreed. Over 60% of the people that responded actually agreed to the recommendation that water treatment system should be in place. Public awareness campaign should be more. Government should enforce stricter penalties for industries and that pollute the groundwater. So I know government has policies in place, but are the policies being implemented? So we keep clamoring they should enforce stricter policies. I know Lagos State is trying to this effect, but when they bring the fine, we are not always happy. But if we do the right thing, we will be happy at the end of the day. So there should be regular testing of groundwater quality. This should be made mandatory. Honestly speaking, as I'm talking, I can't remember the last time I did I tested the borehole water in my house. I don't know if anybody has ever tested their own. When last did you test, or did you even test it after you made the borehole? So this is something we should be doing on a regular basis. We should be testing our water. Then a centralized water supply system should be implemented to reduce dependence on groundwater. If you notice, the world has been in the news. It's been trending now that the level of fresh water is depleting on earth. If you go to places like South Africa, it's very very real there. In fact, the ground fresh water is very expensive. In Nigeria here, well, everybody just go about and we dig boreholes. I know Lagos State is trying to enforce a law about you must inform the government before you dig borehole. What we are getting from the borehole, the groundwater we are getting is fresh water, and fresh water is very very expensive. So, but we can provide fresh water when we have a centralized water system. Water works. There is one at very close to Agbara Water Works. There is one in Lagos State. I know that the problem we usually encounter with centralized water supply system is when they are doing road construction, they cut it off. And when they are done with the road construction, they don't fix it back. In my house, for example, for almost about 20 years, we were getting water from the government. And when the road construction was done, they cut it off until today. This is almost about 13 years after they are still yet to fix it back. So the government should please look into that. So a lot of them agree to this. I'm just re-emphasizing it. The recycling and safe disposal of industrial waste. Not only industrial waste, even our domestic waste. There should be a recycling and safe disposal management system that is in place to take care of our waste, because our groundwater, our surface water, the water system as a whole gets contaminated from our waste. And then community level committees should be formed to monitor and report groundwater contamination issues. So we all have a responsibility within our community to ensure that we monitor how our collective resources is being used, is being utilized to ensure safety for everyone. So all the people in this community, over 60% of them agreed to all these recommendations. So, in conclusion, we found out that this community, Goshofe local government, is significantly polluted by the heavy metals, and the source is not so far fetched. We can see the waste, the landfill that is located here. It's been an eyesore, but the government, I really must commend Lagos State government for how they have kept it. At least it's tidy now. So they've really worked on it. But whatever it is, it's still a source of contaminant because the leachate, I don't know if they have a way of collecting leachate. There's a way you can construct landfills that you will be able to collect the leachate and take it for processing, waste water system and recycling. So if the leachate is still able to get into the groundwater, into the underlying groundwater, then it's still a problem. The solution has not actually been, the problem has not actually been solved. This contamination, this heavy metal contamination, plus other contamination that may arise, correlates with the public health complaint within this community, particularly among the vulnerable groups, the children, the elderly, and the pregnant. So while previous research from the one we mentioned, Babatunde, Ogundele, identified similar trends in Lagos State, this study further exposes regulatory and public awareness gap. So community responses highlighted the need for public education campaign from this table. Industrial accountability, we must be held accountable. Even we must be accountable. How do we dispose of our waste? Improve water infrastructure and local monitoring system, like policing ourselves, so that we ensure we do the right thing. Then policy implications. So for the policy implications, change slide please. For policy implications, enforcement of environmental regulation on industrial disposal, zoning laws to prevent industrial sitting near residential water sources. For these zoning laws, for developed urban communities, I don't know how they can enforce it because we have actually built our residences around these industries. And if they ask us to take our houses out, then legal issues will ensue. So, but for new communities that are coming up, I think this is very important. So we must identify places where the industry will sit and where residential building will also be located, commercial activities at the same time. Then subsidized filtration for community boreholes. So there are ways by which we can purify our water in our home. We can set up a filtration unit to our boreholes before it enters our tank, particularly in places where you have high iron concentration. So, but how the government can help is by subsidizing the filtration unit so that it will be affordable by all. Then integration of water safety into municipal health framework. Nutrition, so groundwater in Koshofe local government is alarmingly contaminated with heavy metals, and this poses a clear risk of public health. And all the recommendations we have made, we actually help to ensure water safety and sustainability. We have done the recommendations. Thank you very much.
The presentation, and we appreciate for Zil for the presentation you have made so far. Before I answer question from the audience present physically here, for some reasons I have to go online just to see how people over there are coping with us. So the first question was what method was used for mercury analysis? 50% hesitance. So in the first instance, I have to respond to the person that asked the question that what did he mean by the question? Can it be on the pollution level? Can the pollution level be up to this? That I asked him to respond, to recast. So after recasting, he now asked the question, was any leachability test conducted on the soil in areas where the samples were collected to suggest the source of heavy metals are from dump sites? Do you get that?
No, we just collected water samples.
Okay,
Within Koshofe local
water
government.
samples. Okay. Then, in addition to his question, how many samples were collected? Two, because NIS or WHO standard requires that not less than 100 samples should be analyzed to make a public health statement. So I don't know.
So this work is actually a preliminary work. So from each of the sites we collected from five and we pulled together. So from that compound. So we have So for some, so if you go to a particular locality where we have wells and boreholes, because they have to take their consent, not everybody allowed us in.
So please,
So for some there were two.
Sorry.
For some there were three.
Those online should be listening now because I'm not the one. I already attended to your question, please. Okay, continue.
So for some area it was two. So it was based on if they have a borehole in their compound or if they had a well in their compound. So in some places we got one, in some we got two. We pulled it together. So, but it's a preliminary work. So at the end of the day, I think we had 10 samples pulled together from each of the sites we went to. 10.
Then, another question from one of the online participants. We have, please, what is the limit of detection of metals with AAS? It cannot determine 0.002 concentration. I know you might have seen some of these things for analysis. So that's a chemical analysis anyway. Then it's talking of it's also talking of a flame AAS. That's an atomic absorption spectrophotometry. I know that one is not well articulated. It's not within the limit of what you are trying to tell us. Because under this one, is trying to say that flame AAS cannot be used for mercury with air acetylene. I know we have some of our chemists that really specialize in this area that can really respond to that anyway. But within the scope of this presentation, I think we have to limit ourselves to some area. So he just said that please recheck the results. Thanks. So that was the second question from the audience online. So if we have some other general contribution, you can please help us talk to that.
Yes, I'm happy you said, okay, let me appreciate your presentation. You have done a very nice job. And I'm happy you mentioned that your work is in preliminary studies. You want to do more work. That is why I want to add values to what you have said. Based on what you have said, that water has odor quantitatively, and you never bother to go qualitatively. One of the days that you use organoleptics to determine whether water has odor or taste. With the latest trends, there are a lot of equipments that can give you the values of the odor. So I will be glad if we can go back to the bench and determine the test level code, test code level of the water, so that you'll be able to know whether you are dealing with a leachate or you are dealing with a fresh water. Because fresh water will never smell. That is one. Now, from the online questions, well, I think I will expect you to revisit the result and recheck using a more high precision analytical equipments. And I would recommend ICPOES so that we're able to know whether the amount of values obtained from AAS is accurate or not. And lastly, from the funding, Professor Ajayi also mentioned that there will be need for you to carry out intensive leachability test. You have to do the leachability test. The first thing you do, you determine whether the water is water or leachate. After getting that it is leachate, then you need to find out the source of leaching. That's what we need. So I wish you best of luck. Thank you.
Yes, okay. My name is Tiwalade Olugbade. I'm a retired professor from OAU. I didn't want to speak this early, actually. I still have some things that I reserved. But at this point, on the technical details, with respect to elementary analysis, there are some details that were missing. Because even when you use AAS, is it graphite furnace? Or because those are the things that will determine the sensitivity, how far you can go. And then elements, I know how technically involved it can be. I've managed one before, if nothing else. And I know that even some of our clients, they do a lot of wrong things before they bring the material to you. Especially these days that things are very, very expensive. Do they use the analytical grade reagents, nitric acid that is meant for AAS, not the general purpose nitric acid that is heavy with metals by itself. So it needs a lot of validation to be sure before we pronounce. And I can tell you that speaking. If you are going for the ultimate, of course, ICPIS. But I can tell you that those who, I don't know if maybe you have one, I don't know. Because managing it or running it, you need helium. It gobs helium like no man's business. And I think, I'm not sure people can easily afford it. Maybe at a regional level, at a central level, maybe something else. But be able, before we can pronounce and challenge ourselves with it, we need to validate the result. I think that's the better. Then the other one, when you took, I would say there was stereotyping about taking water from to Suffolk, to go all those areas and things like that. Did you take for Victoria Land? What was your control? Because I have an impression that there is no good water in Lagos. I have that impression, that bias. Because it's easy to get impression that water elsewhere is better than what even Idiaraba itself. I don't know. I don't know if you have gotten rid of River Idiaraba to talk about. So, and then in the recommendations, you know, it's only in Nigeria that we blame the victim because it's only isolated cases that people dig borehole elsewhere in civilized countries. Water is supposed to be municipal service. Wastage management is supposed to be municipal service. So I don't know how else. Okay, you're even talking about location of industry, relation to relation. Who determines that? When you can show evidence of town planning approval, they are located, even sometimes give you the approval before inviting a company from nowhere, and then the governor signs, and then you are testing knowledge of individuals for about health risk and all the rest of them. I wish there's a way of testing the knowledge of local government chairman, of testing the knowledge of the governor, because that's what matters. All these things are in look at National Health Act. All of them are there. They are there. I wish somebody will even take it as an assignment to do systematic review, because some of these things you are coming across, well, there may be difference about location, about software, but don't be surprised if it's not different from what is found out in Ekiti or Anambra. It's the same problems all over, and they are almost over documented. But maybe you can follow up and get your student to do a systematic review so that you get a collation that can be used as maybe FIPAN itself can take it up and confront government with it. All these isolated individual efforts will probably not add up if the government, I get the impression that government is not serious. You don't have to follow me to say it. I'm saying it at my own risk. But I get the impression that government is not serious. Because you need to ask them, almost all the state governments, they fine on environment. Ask them, what do they do with the fine? Do they apply it to correcting the problem? That's number one. Number two, even when they don't fine, they even levy, environmental levy. What do? I'm happy to say that Ogun State, at least somebody commended Ogun State for environmental wastage management. I don't work for Ogun State government, I only live there. So, but I'm saying it deliberately. There are most of those things, the fines they impose, what do they apply it to? Do they apply it to correct the environmental problem? We even already know that the ecological fund, at least we have record of the case that has gone to court, that the ecological fund is misapplied. So I wish we get to a stage that we can confront our government with data, real data, and see them there. I know that's beyond your scope. I defer my other comments to later.
Thank you very much, sir.
Thank you. Like I said, it's very interesting presentation that concerns all of us and back with me. Just a little addition to the last speaker. I would have suggested you do aluminum, you do ammonium. In many of our environment, it's not only the dump site. We have places where they have abattoir, either the big one or the micro one, that are really affecting the health of the people there. It's a regular thing that we should be checking so that we know where we are. Thank you.
Thank you, sir.
Good afternoon, sir. Good afternoon. Let me commend the researcher. I have also worked on those dump sites. At least I work on Olushosu, the one at Ikorodu, the one at Isolo, and the one at Igondo. I have a question. Please, ma, Osa, did you collect paper from Loma? And what are the challenges that you face? Because when I was carrying out my research on getting to Igondo and Olushosu, I nearly lost my life at the dump site. My life at the dump site. When I was attacked by the area boys, and they were asking and said, I came here to film Lagos, to show to the world the dump site in Lagos. I now told them no, that I'm a student who is working on the dump site. The thing they asked for me is that where is my letter from lawman? That was what actually saved me that day. Then I was doing my second degree in the University of FIPAN. It was the letter I collected from lawman at Ijora and with the one I collected from UR that saved my head that day. So I want to advise that if anybody wants to do a research work in those environments, it's better you meet lawman at Ijora, collect letter that can introduce you to the authority in those environments, so that at the end of the day, you will do your work successfully. Nobody will harass you. Then I also want to know at what depth were those samples collected? Because when I was doing my own, I was given at a depth to collect sample at the surface, at the middle, and the final depth I got to. So that is my own advice. But I also know that there are some companies that have MPAEAS that can carry out better analysis of the heavy metal we are looking for. Thank you.
Thank you, sir. So before we go out for any research, we have to collect data. So yes, we have letters from lawman. Lagos State has to give us data approval, plus the one from our university. Then we go with our ID cards too. So the letter does not only suffice, we also go with the ID card. So apart from the letter and all those ones, when you get to those sites too, you also meet the homoniles that are different from the government. So the government is on one side, the homonile is on one side. So you also go with what you will need to show the homoniles before you collect whatever samples you want to collect. So,
thank you very much. That is what they call give what is Caesar's unto Caesar. Well done. That's wisdom. Madam, just want to say well done and well done and well done again. But I just have this little recommendation to make. My name, okay, I'm Oluseyi Deborah Moemeke. Thank you. Okay, the recommendation is this. I somehow personally is not so comfortable with the pulling of samples like you mentioned, that you get to an area, maybe like 3, 4, 5 boreholes you put together or wells and all that. And the reason being that the reason for all this research is for us to inform government to be able to create positive impact on we, the citizens. Even though we are not living there, some people like us are living there. And we don't want those research to just go wasted. Now, if we want to have informative data that can influence policy decisions, we need to be very, very factual. I would have expected or advised that such sites that you sampled, we need to categorize them. Categorize boreholes. Let wells come out. They are shallow wells, they are deep wells, they are very deep wells. Even the boreholes, if you can get to the extent of you getting to know their depth, it will help. You mentioned something that government, out of remedy due to recommendation, may not be able to relocate the residents. But how can they provide remedy that will be life-saving and life-safeguarding? It can be that they will come up with a policy, having known that, okay, at so depth, the level of this metal contaminant reduces or now fall within normal range, which when it's lower, actually highly contaminated. They might come up with a policy that, okay, if you're going to live here and drill borehole, if municipal water is not available, it must get to this level, this depth. If not, it's not approved. Now that they're even saying that before you drill borehole, you must get approval. So things like this will help us and even make us true professional to really do research that will be impactful to the citizen. Thank you.
Thank you, ma'am. So that means I need a geologist on board now, not just a chemist. I need a geologist on board. Thank you.
Sorry, I'm giving consideration for online people, but I think it's not something so much because we tried to round up very soon too. This person asked that was there any studies of the dump site made to determine the composition of characteristics
No.
or the waste?
No.
Okay.
Strictly water.
So, okay, he was saying that this may have some correlation with the levels of heavy metals in the underground water. Okay. Then has also advised, let me quickly, on the issue of the determination for arsenic and mercury content, as the case may be. They said that a cold vapor or hydride generator should be used for mercury or arsenic. I think the chemists in the house, do you agree with that? So I think that's just the concept. We thank you for the presentation. So I think on that basis, we have to round off for that.
Thank you, everybody. Thank you for
I want to thank everyone present here this afternoon. I want to find out if Dr. Dankara is in the house now. Dr. Dankara. All right. Because he's the next author to present. He's not in yet. Okay. I think I got his phone call. I thought he was already in the building. So probably we can just give him like 6 more minutes to come in. So we'll have 6 more. Let's give him 6 more minutes before we go to the next agenda of the program. Thank you very much. Yeah, very well, sir. I can remember visiting you in OAU.
Yes. Yes. Ladies and gentlemen, I feel happy to be here among you, and especially to participate in this particular exercise. And I'm making my comment with sense of sentiment, if you like. I remember that it took a lot of effort between myself and Professor Mendy to persuade FIPAN to move away from or to create newsletter separate from a journal publication. And of course, we were biased. In the council at the time, the 2 of us were from academics. The others were mostly in practice. And we thought that's the only way we could attract our young ones and colleagues who are developing to contribute things that are meaningful, that are of research. And believing, I have 2 issues, 2 comments to make on it. One is that the universities, including my own, have systematically disappointed me in respect to the credibility it gives to assessing local journals in the first instance. Local journals are necessarily rated low in academic career, and that will be the reason why you don't have sufficient subscription. Because if you are mentoring a young person in academic, you will have to tell him, you may not be able to defend him as he climbs in his career when local journals are downgraded and international journals are highly rated. And so that's number 1. Number 2, well, the implication of that is that most of the time, when our colleagues have very good articles, they try it out in international journals. It's only when they are rejected that they now consider local journals. Then number 2, so I can speak and defend local journals because most of these kind of presentation we make, they will be rejected not because of the merits of the content, but because whether you believe it or not, even the international publishing houses are commercial organizations. They are not owned by WHO or United Nations. They are based on business, so they are boardroom decisions. So why will water content in Kosofe attract a reader in California? So why will he subscribe to it? Those are the basis of taking some decisions. So what I'm saying in essence is that we should, especially those of us who are senior, we should try to promote the local journal, and we should also try to defend it in our institutions. Otherwise, we get to the level that I can say with pride that I had to volunteer an article to the first edition just to make this point because I was in the editorial board with Professor Mendy as chairman at that time. And I was embarrassed that when the journals were being distributed, this was 2013. That is one reason why such a journal will not be given any rating or ranking or cited, because it's not maintaining publication. Yes. So I want to challenge the correct, and I was embarrassed, further embarrassed when I look at the editorial board. I still find Professor Mendy as the editor-in-chief, and I still find my name in the editorial system, and our retired professors too that are still servicing them. So please, if they can change the orientation, that we have a duty to promote